Good morning, everyone. We will solve this problem on spheres. Here in this question, we have three spheres A, B, and C. If you compare it with the previous problem, the weight of the previous spheres were same and diameter was same. But in this question, if you see, weight of A and B is 4 kilonewton. Weight of A and B is 4 kilonewton. Weight of C is 6 kilonewton. Weight of C is 6 kilonewton we have. Next, diameter of A and B is 500 mm. A and B is 500 mm. C is 800 mm. So, if you see the inclined surface, one is inclined at an angle of 75 degrees, other is inclined at an angle of 65 degrees. Distance between A and B is 600 mm. So, the question asked is determine the reaction at contact points. Wherever it is having contact, there the reaction develops, that has to be calculated. So if you see the sphere A, it is touching this inclined surface at P. So therefore here the reaction develops, it has to be calculated. If you see it is touching this horizontal surface at point O, so here reaction develops, it has to be calculated. So sphere A is touching the sphere C at point K. So here one reaction has to be calculated. Then next, if you see the sphere B, this is touching this point N. So here one reaction developed, this has to be calculated. The sphere B is touching this surface at point M. So here reaction has to be calculated. And B is touching the C at point L. So here reaction has to be calculated. So totally we have 1, 2, 3, 4, 5, 6. 6 reactions have to be calculated. So we'll try to draw the free body diagram. So before drawing the free body diagram, let us calculate at what angle this reaction would be inclined. Correct? If you see this triangle A, C and D, so the diameter of this sphere they have given it as 500 mm. So the radius will be 250 mm from A to K. So diameter of C is 800 mm. So from here till here radius will be 400 mm. So total will be 650. AC will be equal to 650. Next is this total AB length is 600 mm we have. So half distance will be 300 mm. So this is 300. So we have to calculate this angle theta. Theta will be equal to, cos theta will be equal to 300 by 650. So theta will be equal to 62.51. The reaction which will be developed at point K, it will be inclined at an angle of 62.51 degrees with respect to horizontal. We'll try to draw the free body diagram of this point sphere C. Sphere C. This is the free body diagram. So the self weight of the sphere is 6 kilonewton. Self weight of the sphere is 6 kilonewton. Always weight is going to act in downward direction. This is what is shown. Next is this C is touching this point K. So reaction will be developed somewhat like this. So here that is RK we have. So RK we have written, which is inclined at an angle of 62.1 degrees with respect to horizontal. Next is at point L reaction develops. So we have taken it as RL. So reaction will be developed somewhat like this. This is what I have shown. So angle will be 62.51 degrees. So if you consider the sphere C, we have two reactions plus one self weight. Two reactions RK, RL and self weight is 6 kilonewtons we have. So now three forces and they are concurrent coplanar forces. So therefore we can apply the Lami's theorem. So if you apply Lami's theorem to this figure, so we will take this 6 kilonewton. 6 kilonewton will take force divided by sine of angle between other two forces. Other two forces means RL and RK. So this total angle has to be taken. If you add up 27 plus 27.49, it will be 54.98 degrees. So that is equal to, next is we will take RK. RK divided by sine of angle between other two forces, that is RL and 6 kilonewton. So this angle has to be taken. So this angle will be equal to 90 plus 62.51. If you add up, you will get 152.51 degrees. So it is sine of 152.51. Then next is we will take this RL, that is RL divided by sine of angle between other two forces. Other two forces is this, so this angle has to be taken. So therefore it is 90 plus 62, it will be sine of 152.51 degrees. So this is the equation after applying the Lami's theorem. So we will take these two equations and we will try to solve it first. So if you cross multiply, you will get RK value as 3.382. If you take this equation and this is equal to this, again it is same. So therefore RL will be equal to 3.382 kilonewtons. Next we'll apply, we'll draw the free body diagram of this sphere B. Sphere B. So if you see this sphere, this is self weight of the sphere. It is going to act in downward direction. Self weight is how much? 4 kilonewtons. 4 kilonewtons. It is going to act in downward direction. Next is it is touching at point M. So normal to the surface, reaction develops. So therefore here we have shown it as RM, right? If you want to calculate, so this will be 90 degrees. So with respect to horizontal it will be 25, or with respect to vertical it will be 65 degrees. Next is at point L, it is touching the surface. We have shown this as RL. Already we have calculated this angle 62.51. So it is with respect to horizontal it is 62.51. So here in this case we have four forces, so we cannot apply Lami's theorem. So therefore we will apply the conditions of equilibrium. So first we will apply summation of f of x is equal to 0, forces acting along x direction. So if you see this RL, if we are going to resolve it along x direction, so RL, if you see the arrow, it is going to move towards right, so therefore it is positive. So along the angle, if we are resolving, it is cos. So RL cos of 62.51. Next we will resolve this RM. So if you resolve this RM along x direction, so if you see the arrow, it is going to move towards left side, so therefore it is negative. So it is, we are resolving away from the angle, so therefore it is sine 65 degrees. So therefore it is minus Rm sine of 65 degrees. This and this, they are vertical, it cannot have any component along x direction. Due to this it will be 0. So therefore that has to be equated to 0. Next, if you solve this equation, you will get Rm is equal to 1.722 kilonewtons. We will go to the next equation, that is summation of f of y is equal to 0. If you take this Rn, it is moving upwards, so therefore positive plus Rn. Next is, if you take this 4 kilonewton, if you see the arrow, it is moving downwards, therefore it is minus 4. Next is, we will resolve this RL along x direction. So if you see the arrow, it is going to move towards right side. So therefore, so this has to be resolved along y direction. This has to be resolved along y direction. If you see the arrow, it is going to move downwards, therefore it is minus. And we are resolving away from the angle, it is sine of 62.51 degrees. Then next is, we have to resolve this Rm along this y direction. So therefore, if you see the arrow, if we are going to resolve, it is going to move upwards, therefore it is plus. So we have Rm, we are resolving along the angle, so therefore it is cos of 65 degrees. So that has to be equated to 0. If you are going to solve this equation, you will get value of Rn, that is equal to 6.272 kilonewtons. Next, we will draw the free body diagram of sphere A. We will draw the free body diagram of sphere A. If you see, so self weight is going to act in downward direction. This is self weight, that is 4 kilonewtons. Here is the self weight what we have. Next is this is touching this point O. This is touching this point O. So reaction develops normal to the surface, that is RO, which is moving upwards. Next is at point P, the reaction develops normal to the surface. We have shown this as RP. So if you want to calculate the angle, if you are going to draw normal to this, so this is 75 degrees, so this will be equal to 25 degrees, this is 90 degrees. As this is 90 degrees, this has to be 25 degrees. So with respect to horizontal, it will be 25 degrees, or with respect to vertical, it will be 75 degrees. Then next is RK, reaction which is developed equal and opposite. So we have shown RK, which is acting at an angle of 62.51 degrees. So again here we have four forces, so we cannot apply Lami's theorem. We will apply the conditions of equilibrium. First we will apply summation of f of x is equal to 0. You resolve this force along x direction. RP has to be resolved along x direction. So therefore if you see the arrow, it is going to move towards right. So therefore it is plus. We are resolving away from the angle, it is sine of 75 degrees. Next we will try to resolve this RK along x direction. So if you resolve it along x direction, it is going to move towards left, therefore it is minus. We are resolving away, along the angle, it is cos. So therefore it is RK cos of 62.51 degrees. So that has to be equated to 0. This and this, they will not contribute in the x direction. If you solve this, already we have calculated value of RK. So if you substitute, you will get the value of RP, that is 1.616 kilonewtons. Next we will apply another condition of equilibrium, that is summation of f of y is equal to 0. All the forces has to be resolved along y direction. First if you take this arrow, it is moving upwards, therefore plus arrow we have. Next if you take this 4 kilonewton self weight, it is, if you see the arrow, it is moving downwards, therefore it is minus of 4. Next is if you resolve this RP along y direction. If you resolve with this, if you see the arrow, it is moving upwards, therefore plus. Along the angle we are resolving, therefore it is cos. So therefore it is RP cos of 75 degrees. Next is we have to resolve this RK along y direction. If you see the arrow, it is going to move downwards, therefore it is minus RK. We are resolving away from the angle, that is sine. So sine of 62.51 degrees, that has to be equated to 0. So if you solve, if you substitute value of RP and RK what we have calculated, you will get the value of RO. So value of RO will be equal to 6.582 kilonewtons. Thank you.